Hello everyone. Let's take a look at our next problem. Let R1 be the region bounded by y equals x squared, y equals 0, and x equal b, where b is greater than 0. Let R2 be the region bounded by y equals x squared, x equals 0, and y equals b squared. Is there a value of b such that R1 and R2 have the same area? Okay, so we have two regions here that are each of them bounded by three curves. And in each case, one of the curves depends on an unknown parameter. And we're basically asked a question about the area of these regions. So what I want to do is just compute the area of each of these regions as it depends on the parameter b, and then see if these two areas, which we can think of as being a function of b, if these two functions of b have a point of intersection. Okay, so region 1 is given in terms of the area enclosed by three curves, where b is greater than 0. So if we draw what this looks like, so we have y equals x squared, y equals 0, which is this axis, and x equals b, which is just a vertical line. So this in here is R1. So a1, which is a function of b, in this case is just going to be the integral from 0 to b of x squared dx, which is b cubed over 3. And now for the second region, the second region is given by the curve y equal x squared, x equals 0, and y equal to b squared. So what does this look like? It's going to be slightly different than our than R1. So there's the parabola again, and then this is that's the curve x equals 0. It's the y-axis itself. And then for some value of b, I suppose if that's b, then this is b squared. And so this now is the region that we're interested in. And I think the easiest way to compute the area of that region is to think of this rectangle. Notice, if you look at these two, if you look at the two figures here, this region here, that's R1. So R1 and R2 together form a rectangle. So the way I'm going to write this is area 2 as a function of b is just the area of the rectangle, which is b cubed, minus a1, which is a function of b. But we've computed a1 already. It was equal to b cubed over 3. So a2 is equal to 2b cubed over 3. And the question is asking, are there any values of b for which these are equal? Well, if we set these two things equal, we'll see right away that we're not going to find a value of b which makes them equal. a1 is b cubed over 3, and a2 is 2b cubed over 3. So we already have the restriction that b is strictly positive. That was given to us at the beginning. There's no values of b which make this equal, the two sides of this relation equal. This has no solutions with b greater than 0. Therefore, the two areas are always different. Yeah, that was fairly straightforward. Just computing areas of things defined geometrically. We could have found this area in a different way by integrating in the y direction rather than the x direction. But once I drew the figure, I realized right away that regions 1 and 2 together form a rectangle. So it was a lot easier to just do it that way. Thanks for watching.